The identification map here is a visual representation of the identification results table for each element. It can be used to identify areas in the analysed sample in which a given element is present. Note that this map is only generated if a multi-acquisition file is analysed, such as the one we have here, so spectra have been acquired from several positions on the sample. The map is titled with the element and the spectrum number to which it relates, so in this case nickel and spectrum 1. But if we update the spectrum number to map, the map will be updated accordingly. So now spectrum number 2. Or if we change the element, say to chromium, it's now chromium in spectrum 2. Just return those values to what they were. The identification result at each measurement location is marked using coloured concentric rings. The colour of the rings corresponds to the identification result and is the same as that indicated in the table of results. So green indicates that the element was identified as being present, orange that the identification was inconclusive, and red that the element was identified as being absent. The central point in each marker identifies the coordinates of the measurement. The inner ring represents the laser spot diameter and the outer ring the crater diameter as specified in the mapping configuration. So if we have a look at the mapping configuration, we can see the crater diameter has been set to 0.5 millimeters and the spot diameter to 0.25 millimeters. Note that the crater and spot diameters are simply indicative values entered by the user. From this map we can see that in the first spectrum acquired at each location, nickel has been identified mainly in the left-hand side of the sample. The map scale can be modified by left-clicking on the axis limits to edit the maximum and minimum scale values as required. In this way it is possible to zoom to a specific region of the sample if required. Note that doing so also updates the scale of the intensity map. To return the map to the initial scale, select this button. Left-clicking on any point of the mapped results will display the measurement coordinates, identification result, and the peak intensity for the selected element at that location in the small window to the right of the map for as long as the mouse button is depressed. So if we click on this point here, we can see this is point x equals 2, y equals 2. The identification result was that the element was present and the peak intensity is 4.5 times 10 to the 3. Click on a different point. That's x equals 3, y equals 0. The element was absent and the peak intensity was 2.92 times 10 to the 3. Selecting this button to the right of the map will display both the identification and intensity maps full screen. The functionality of the maps is just the same as before, so we can left click on a point to display the values associated with it. We can change the scale ranges, and to return to the main element identification screen we simply click on this button.